Example 7, we're asked to find the surface area of this composite figure. This is a really cool problem. I like this one for a couple reasons, but it can be a little bit difficult to visualize. So what we have going on here is a cube with edge lengths of 2 yards, and out of that cube we've scooped out a square pyramid. So for the surface area of this problem, let's think about what surfaces we have exposed. For the cube, we have 5 of the 6 faces exposed. Okay, the bottom and then the 4 lateral sides. What's missing is this top of this box. Instead of having a top, okay, we have surfaces going down into it that are scooped out. So we're actually increasing the surface area of this figure as opposed to if it were just a normal cube. Okay, a normal cube would just have this flat top to it. It has its area on there and you're done. Instead, though, you're now increasing the surface area because now you have 4 of these triangular faces that you need to add on. So let's think of this as 5 of the faces of the cubes. Okay, they're also bases, so let's just say 5 times b. And then to that, we're going to add on these 4 lateral areas, or 4 lateral faces of a square pyramid, which is the lateral area of that pyramid. Okay, so that's the general procedure that we're following here. And now we can get into calculating these values. So for those 5 faces of that cube, we know that they're each squares, okay, each with an area of 2 squared. So we can just do 2 squared for an individual area. We'll multiply that by 5 because, again, we have the 4 laterals and then the 1 bottom base. We do not have a top to that cube. For the lateral area of this pyramid, we know that lateral area is 1/2 the perimeter of the base times the slant height. So perimeter of the base, we know that that is 4 times 2, or 8. Now the slant height, that's probably the trickiest thing to find in this problem. Let's take a look at what's going on here. We know that the slant height comes down perpendicularly down one of these lateral faces to the base edge. In this case, let's look at the front face of this inverted pyramid. The slant height is going to be coming down perpendicularly right there. So we need to figure out what that length is. Now, the only measurements that we have in this problem are the base edge length for the cube. Okay, so if we were to envision an inverted right triangle in here, we can kind of visualize what's going on. Let me pull this out and redraw this so we can see this in a more conventional way. We know that the height of this is going to be 2. Okay? And this distance here is going from the center of that square base out to the edge. So you're really cutting that in half. So we have 1 unit for that. And this slant height is the hypotenuse of this triangle. That's what we're trying to find. So we can do a Pythagorean theorem to get that slant height. Okay? That slant height here is going to be the square root of, we're using a modified Pythagorean theorem here so that we can go directly to that hypotenuse. 1 squared plus 2 squared. We know 1 squared is 1, 2 squared is 4. So this slant height is going to be the square root of 5. Okay? And that's what we can substitute back in here. So now we can add these components together. Okay? Going back to the bases, the 5 bases, 2 squared is 4. So multiply that by 5, we have 20. We can really let the calculator take over here and get a rounded final answer. 20 plus, let's see, 4 times 2 is 8, half of that is 4, so we'll multiply by 4 times the square root of 5, and we get a composite surface area of 28.9 square yards. Now, one last thing about this. This is kind of a cool problem for a couple reasons. One, with the calculations and how you think about this, but let's envision that we had a very similar figure here, but instead of that pyramid being scooped out of it, what if you had that pyramid sitting on top of it? Like that. The cool thing here is that this would have the exact same surface area as the one with the pyramid scooped out of it, like we just calculated. Because think about what you'd be calculating here. We have the 5 faces of this cube plus the 4 lateral faces for that pyramid. It doesn't matter that they're not scooped out of the cube, it's now sticking up top. Okay, they're still exposed surfaces. So I think that's a pretty cool connection here between these two surface areas. Now the volumes would be different, and we'll look at that next week.